Something cracked open on the north flank of Mount Etna on August 15th, 2026. Not metaphorically, not in a model projection. The ground physically split along one of the most watched geological fault lines in all of Europe. And when it did, the shaking was violent enough to send tourists running from overcrowded hotels and restaurants on the volcano's slopes. A magnitude 3.9 earthquake, shallow, just 1.2. Kilometers below the surface, struck the northeast rift zone at 12:24 in the afternoon, its epicenter sitting 2.8 kilometers north of a place called Piano Pernicana. The Mareneve road, the main artery connecting the town of Linguaglossa to the upper volcano, cracked and split in multiple places. Evacuations began, and while emergency personnel were trying to restore order, Etna was still erupting, active lava. Flows from at least 4 flank vents were advancing down the eastern slope into the Valle del Bove. An ash plume from the northeast crater had punched to 14,000 feet above sea level just hours earlier, and the question that volcanologists at the INGV Etna Observatory, that seismologists, that anyone who truly understands this mountain were now asking openly was this: is the Pernicana Fault moving in response to fault moves? It is not an ordinary earthquake. It is the volcano communicating something about what is happening inside it, about pressure, about magma, about the stress being placed on the architecture of Europe's most active volcano at a time when that volcano is erupting vigorously from multiple vents simultaneously. And right now, as of August 17th, 2026, Etna is doing exactly that. We are going to cover every piece of this story today using the latest verified data from the INGV, the Volcanic Ash Advisory Center in Toulouse, and field reports from ground personnel who visited the volcano on the day of the earthquake itself. By the time we reach the end of this video, you will understand what is actually happening at Etna right now, why the Pernicana Fault is the single most important thing scientists are watching, and what the scenarios ahead genuinely look like. Start with what most people watching from outside Sicily do not know. Mount Etna is the most continuously active volcano in Europe. Since 1500 BC, it has had at least 186 historically documented eruptions, erupting on average every 19 years, with many individual eruptions lasting more than a year. But Etna is not simply a volcano that produces lava from its summit and leaves it at that. It is a geological system of enormous complexity, one that includes summit craters, multiple rift zones that extend outward from the peak, an eastern flank that is geologically unstable, and a fault network that reacts dynamically to every pulse of magma that moves through the mountain's interior. To understand what happened on August 15th, you need to understand that Etna has been in an exceptionally active state for months. The current eruptive phase began on the evening of December 24th, 2025, with a new fissure opening on January 1st, 2026, at 2,100 meters elevation on the northwestern flank of the Valle del Bove, feeding a lava flow that was continuously monitored by INGV's Etna Observatory. That eruption was remarkable in its own right, but it was a prelude. What came next, starting in early August 2026, pushed Etna's activity into a different category entirely. Etna's new eruption, which began on August 6th, 2026, appears to have become something more than an ordinary event. While the Voragine crater spewed large columns of ash for the 4th consecutive time, the ground below 2,900 meters continued to crack. Strombolian activity at the Voragine's crater progressively intensified, becoming more sustained and frequent starting around 1930 UTC, evolving into lava fountaining activity. And the critical development, the one that changed the picture dramatically, was what happened to the eastern flank. By the afternoon of August 11th, 4 effusive vents were open on the eastern flank of Etna, specifically along the north face of the Valle del Bove at the foot of 2,090 meters and 5,900 meters, with the most advanced lava flow fronts reaching 1,365 meters near Rocca Capra in the Valle del Bove. Etna has always been particularly fragile on its eastern flank, which tends to slide slowly toward the sea. But this same fragility allows lava, when it searches for a passage to the surface, to easily pierce the ground in that very area. Scientists at INGV were watching this progression carefully, tracking how far the lava was advancing, monitoring tremor levels, maintaining surveillance of all 4 active flank vents. And then came August 15th, the earthquake, the cracked road, the evacuated tourists, and the moment the Pernicana Fault reminded everyone that at Etna, the ground beneath your feet is never truly still. The Pernicana Fault has a reputation among volcanologists that goes well beyond its modest appearance on a geological map. It runs roughly east to west across the northern flank of Etna, extending from the upper reaches of the northeast rift zone down to the lower volcanic slopes near the town of Sant'Alfio. From the air, it looks like a scar, a long lateral wound across the face of the mountain. But what it represents structurally is far more significant than its visual. Impression. The southeastern flank of Etna slides into the Ionian Sea at rates of centimeters per year, and along the northern boundary of this unstable flank, deformation focuses along the left lateral Pernicana Fault. To the south, the Tremestieri and Asitrezza fault systems accommodate most of the flank movement. In other words, the Pernicana Fault is literally the upper edge of a massive wedge of volcanic rock that is in slow, continuous motion. It is a boundary between the relatively stable upper volcano and the part of Etna that is sliding away from it. Fault dynamics along the Pernicana are characterized by continuous creep movements associated with the eastern flank sliding, punctuated by shallow earthquakes with maximum magnitudes around 4.7 and depths of 1 to 4 kilometers, producing coseismic fault displacements. The seismic activity occurs in connection with the intrusion processes that lead to flank eruptions, as well as non-volcanic causes. That is an extremely important sentence. Seismic activity on the Pernicana occurs in connection with intrusion processes that lead to flank eruptions, not after them, not coincidentally with them. In connection with them, meaning the fault and the intrusive magmatic system are coupled. When magma pushes into the northeast rift zone, the Pernicana Fault responds. And when the Pernicana Fault responds, it tells geologists something about the state of that intrusion. The Pernicana Fault system can be considered as a gauge of any instability occurring on the eastern flank of the volcano. Studying and monitoring its activity provides first-order insights on flank instability and how it may be affected by shallow intrusions. The word gauge is precise and deliberate. These researchers are not using it loosely. They mean it the way an engineer means it when describing an instrument. The Pernicana Fault is a measuring device built into the geology of the mountain, and when it moves, it is giving a reading. What scientists now need to determine is what the reading from August 15th's M3.9 event is actually saying. Is it measuring the end of the current eruptive episode, a deflation signal as magma pressure releases? Or is it measuring the beginning of something new, a fresh intrusion pushing laterally into the northeast rift zone? When this fault moves, it often means that the volcano is swelling and filling with lava, or conversely, that it is deflating at the end of an event. In the past, the fault has also moved shortly before, a lateral eruption. Even based on these parameters, the situation could represent the end of an event, but without absolute certainty. That careful, layered uncertainty is not hedging. It is an honest representation of what Etna science looks like at the cutting edge. The volcano is not a simple system, and its signals do not always point cleanly in one direction. The same seismic signature on the Pernicana Fault can precede either an escalation or a de-escalation, depending on what is happening in the magma plumbing beneath it. This is why INGV's monitoring is not just an observatory function. It is active geological interpretation conducted in real time, around the clock, on one of the most complex volcanic systems on the planet. What makes the August 15th seismic energy release? A shallow earthquake in the Pernicana system releases energy close to where fault displacement translates directly into surface rupture. This is exactly what happened at the Mareneve road. On the afternoon of August 15th, the north flank was shaken by the magnitude 3.9 earthquake about 1 kilometer deep, which caused panic in the area's overcrowded hotels, shelters, and restaurants. People were evacuated, and even during these operations there were disruptions, because the Mareneve road split in several places. A road cracking open during an earthquake evacuation is not a footnote. It is direct physical evidence that the fault displacement was real, measurable, and surface-reaching. Historical precedent adds further weight to this concern. The M3.7 event of September 22, 2002, represents an exemplary case in which the seismic release preceded by nearly a month the violent and dramatic explosive effusive flank eruption of October 2002 to January 2003. That 2002 to 2003 flank eruption was one of the most destructive in Etna's modern history. It destroyed the tourist facilities at Piano Provenzana, produced lava. History is about to repeat itself. But they are aware of the precedent. They have the data. And the 2002 earthquake near the Pernicana system is exactly the kind of case study that flashes through the minds of volcanologists when a shallow M3.9 strikes in precisely the same fault zone 2 decades later, during an already active multi-vent eruption. What was happening to the lava flows at the same time as the earthquake hit deepened the picture further. The effusive activity from the recently formed vents at elevations of 2,750 meters and 119 to 90 meters continued on the morning of August 15th when personnel from the Volcano Observatory visited the volcano. The leading edge of the lava flows had reached an elevation of approximately 1,600 meters near Rocca Musara, overriding previous flows. That phrase tells you the lava advance was not slowing. The most recent material was burying older material, which means the effusion rate remained sufficient to push the flow front further down the flank. At the same time, the northeast crater was showing its own independent signs of activity. At 10:40 local time on August 15th, a brief explosion occurred at the northeast crater, generating an ash plume that, according to dispersion forecast models, drifted southward. Summit explosions and continuing flank. Lava flows simultaneously on the same day as a shallow M3.9 along the Pernicana Fault. This is not a single isolated signal. This is a convergence of signals that together paint a picture of a volcano under significant and multi-directional stress. To understand what Etna might do next, it helps to understand the internal architecture that makes this volcano's eastern flank so fundamentally different from the rest of the mountain. The eastern flank is not simply a slope, it is a geological entity in its own right, a massive wedge of volcanic rock that accumulated over hundreds of thousands of years of eruptions and has been moving eastward for most of that time. The prevailing understanding is that pressurization of the magmatic system drives the flank's motion. Magma, pushing upward and outward from the central conduit and the rift zones, inflates the volcano's interior, and that inflation exerts stress on the flanks. The eastern flank, sitting on weaker geological substrate and inclined toward the sea, absorbs that stress by moving, slowly, centimeters per year under normal conditions. But the key word is normally. The northeast rift zone, directly above where August 15th's earthquake originated, is one of the two primary structural highways that magma uses when it travels laterally away from Etna's summit. The northeast rift plays a very active role in the activity of Etna for its extensional tectonics, which allows the intrusion and residence of magma bodies at various depths, and for the interaction it has with seismogenetic structures. When scientists at INGV reported that the M3.9 earthquake could potentially involve an activation of the northeast rift zone, the rift pushed the Pernicana Fault northward and potentially opened new eruptive vents on the upper northern flank of the volcano. That is a very different kind of eruption from what has been happening in the Valle del Bove, and it would directly threaten populated areas on the northern slope that the current eastern flank eruption does not. The comparison between eruptive sequences and historical seismicity reveals that the large earthquakes which struck eastern Sicily occurred after long periods of activity along Etna's rift zone. The larger the erupted lava volumes, the stronger the earthquake. That relationship is not theoretical. It has been measured, documented, and replicated across Etna's modern eruptive history. The more lava Etna erupts from its rift zones, the more stress accumulates in the fault systems that border those zones. And 2026 has been an extraordinarily productive year in terms of lava output. The January fissure alone produced sustained lava flows for weeks. The August eruption opened at minimum 4 flank vents simultaneously. The cumulative lava volumes from this eruptive sequence are significant, and that means the stress loading on the fault systems, including the Pernicana, is also significant. The INGV's response to August 15th was measured, as institutional scientific communication on an active volcano always must be. By the morning of August 16th, they had issued communications characterizing the alert status as orange, meaning the red emergency level of peak eruption had passed, but that the situation remained actively monitored and unresolved. The latest official press releases from INGV issued on August 16th speak of an orange alert, meaning the emergency is over, but it is unclear how things will develop. That statement carries important weight when you read it carefully. Not that the emergency is definitively over, that the emergency of the peak eruption phase has passed. Whether things remain at orange or escalate or gradually de-escalate depends on what the mountain does next with the pressure it is still clearly carrying. There's another layer to this story that has received almost no attention outside of specialist volcanology circles, and it is perhaps the most striking geological development of Etna's 2026 eruptive season. Between June 22nd and July 7th, 2026, a new eruptive episode fed a lava flow on the eastern flank from a vent at about 330 meters, and on July 5th produced a paroxysm from the Voragine crater whose ash plume forced the temporary closure of Catania Airport. The Voragine crater. This is significant. Advisory Center in Toulouse issued an advisory warning of a volcanic ash plume rising to an estimated 16,000 feet at flight level 160, moving at 20 knots in a southeasterly direction. During the paroxysm of July 5th to 6th, ashfall was reported on the southeastern flank. Airlines operating into Catania, Sicily's busiest airport, just 27 kilometers south of the volcano's summit, have been dealing with disruption and closures throughout this eruptive period. Catania sits directly in the path of the prevailing ash dispersal corridor when Etna erupts with southward or southeastward plume drift. For the people of eastern Sicily, this is not an abstract geological story. It is the backdrop of daily life during the peak summer tourist season, and it is playing out against one of the most sustained and multifaceted eruptions Etna has produced in years. What residents on the northern flank in the towns of Linguaglossa, Piedemonte Etneo, and the broader area around Piano Provenzano are watching most closely right now is the Mareneve road and the Pernicana Fault. The road is both an evacuation route and an indicator. When it cracks, it means the fault has moved. When it moves, the question of whether fresh magma is intruding into the northeast rift zone becomes not academic, but urgent. So where does Etna stand as of August 17th, 2026? The freshest data available as this script is being written. And what should the people in its shadow be watching for in the days and weeks ahead? The most current picture is this: the explosive effusive eruption that intensified dramatically from August 6th onward, producing ash, plumes from the Voragine crater, and simultaneous lava flows from at least 4 flank vents on the eastern face has moved into a less acute phase. As of August 12th, the volcano's activity, both lava effusion, read carefully. Decreasing surface expression does not equal decreasing internal activity. Tremor reflects what is happening in the conduit system at depth, and if tremor remains high while lava output falls, it can indicate that pressure is building somewhere rather than releasing cleanly. The leading edge of the lava flows had reached approximately 1,600 meters near Rocca Musara by August 15th, overriding previous flows. That represents a significant advance down the eastern flank. The Valle del Bove, the enormous natural depression on Etna's eastern side, has been channeling lava flows for the entirety of this eruptive episode. The Valle del Bove acts as a natural containment basin for eastward moving lava, which is fortunate because it means the flows are advancing into an uninhabited geological depression, rather than directly toward populated areas. However, the Valle del Bove is not infinitely large, and lava flows that override previous deposits, as the August 15th observations confirmed, are building up the floor of that basin progressively. The further the flows advance down the Valle del Bove, the closer they come to the lower flanks, where the terrain opens up toward populated coastal communities. The aviation color code from the Toulouse VAAC as of August 17th remained at red for active eruption phases, with orange for the periods of diminishing ash output. A strong eruption was ongoing as of August 16th at 1620 UTC, with a volcanic ash plume rising to 16,000 feet moving southeastward at 20 knots. This means that as recently as yesterday, a full day after the M3.9 earthquake and road cracking on the northern flank, Etna was still generating ash at altitudes that directly affect aviation corridors over the central Mediterranean. The eruption has not ended. It is modulated. And modulation at Etna, as its eruptive history repeatedly demonstrates, does not mean conclusion. For the communities around Etna right now, the practical hazard picture breaks down into several distinct zones. On the eastern flank and in the Valle del Bove, lava flow advance remains the primary concern. INGV personnel are conducting on-site inspections, and the lava flow fronts are being tracked at the resolution of individual field visits. No residential areas are currently directly threatened by these flows, but monitoring continues around the clock. On the northern flank, along the Mareneve road and the towns connected to it, the primary concern has shifted to the Pernicana Fault and the possibility of further shallow seismicity. Road damage is being assessed and repaired. Access to the upper volcano on the northern route has been disrupted. Residents For the people of Catania and the Sicilian communities downwind on the volcano's southeastern to southern flank, ashfall remains the ongoing practical hazard. During active eruption phases, ash and tephra can accumulate rapidly on vehicles, roads, agricultural land, and solar panels. Catania Airport continues to operate with disruption protocols active, meaning that rapidly escalating ash plume events can trigger short-notice closures. Travelers in and out of eastern Sicily should maintain awareness of the current volcanic alert level and check official sources before departure. The Italian Civil Protection and INGV's Etna Observatory both maintain publicly accessible real-time updates. The larger scientific question, the one that the August 15th M3.9 earthquake injected into this story with force, remains genuinely open. Is the northeast rift zone being intruded by a fresh magmatic body? Is that intrusion causing the Pernicana Fault to move in a way that indicates a new lateral flank eruption may be in preparation? Or is the current seismicity simply the dynamic response of the fault system to the ongoing pressure changes associated with the existing eruption? A signal of adjustment rather than escalation? The honest answer, as of the data available on August 17th, is that scientists do not yet have enough information to choose definitively between these interpretations. INGV's monitoring network will provide that answer in the coming days through tiltmeter readings, GPS deformation measurements, and seismic tremor analysis. The signals are being gathered in real time. What is not in question is Etna's fundamental nature. This is a volcano that has been erupting almost continuously since December 2025. It has opened a January fissure, produced July airport closures, generated August multi-vent flank eruptions, and now delivered a rift. Reading is real. The gauge has spoken. What it is saying with complete precision, only the next hours and days will clarify. If you are in Sicily right now or planning to visit, the authoritative source for current conditions is the INGV Etna Observatory website and their official bulletins, updated multiple times daily. The Civil Protection Etna emergency telegram channel at T.me Etna Emergency provides real-time escalate. It rarely gives much warning. The people who live in this mountain's shadow have understood that for centuries. The volcano has always been in charge here. August 2026 is simply the latest reminder.